So I itself, we discussed yesterday, is equal to the square root of negative 1. I is equal to the square root of negative 1. So I is really equal to I. And for those of you that were absent, I represents the square root of negative 1. I squared would then represent I times I, but that would be like the square root of negative 1 times the square root of negative 1. And we said if you multiply two square roots together, you get what's underneath. So square root of negative 1 times square root of negative 1, where the i's are unique, is equal to negative 1. What's crazy is it's on my laptop as the 1. It's just not up there. It's our internet. All right. All right. I cubed is like I squared times I. But I squared is now always equal to negative 1. So anytime you see an I squared, it becomes a negative 1. No. I specified like 10 times the homework was 5 to 16. Yeah. So I squared times I is equal to negative 1 I, or just negative I. You don't have to write in the 1. Yep. So what's if it's I squared times I squared is equal to, okay, but I squared is equal to negative 1 for both of them. So negative 1 times negative 1 is going to become positive 1. So I to the 4th is equal to 1. These are what we call the powers of I. The powers of I repeat every cycle of 4. So there are only 4 choices if I ask you to tell me the power of I. It's I, negative 1, negative I, positive 1. That is it. If I give you an I to any random number, you got a 25% shot of getting it right. And then your shots go up higher because evens never have an I in the answer, and odds always have an I in the answer. So I to the 5th, you got 2 shots here, right? It's either I or negative I, and what's it got to be? Because if you go from 4, you go right back up to positive I, because 4 to 5. So if I1 is equal to I5, because it's like the next multiple of 4, I squared is negative 1, so I to the 6th is also I cubed is negative I to the 7 is odd, so it's got to have an I in it. This one is odd because it's equivalent to I cubed. Because it's 4, it's 7 plus 4 to get, or 3 plus 4 gets you to 7. It works on a multiple of 4. So all multiples of 4 are always going to be equal to 1. So I know it's not on there, but I to the 9 would then become what? I, because you go right back to the beginning. So if you go down to your examples, I to the 13 is I, because what's right and less than 13? 12. And 12 is a multiple of, so therefore, since it's one more than the last multiple of 4, it's I. Okay, yes. Negative I, perfect. Because it's I to the 11. So the multiple of 4 near 11, or less than 11, is 8. So to get from 8 to 11, you add 3, which means I to the 11 is equal to I cubed. But I cubed is negative I. Now, what happens when your numbers get kind of big? I'm going to teach you how you can do this on your calculator. So what I want you to do is we're going to talk about the remainder of a number. So, the next number here, technically after 8, is 9. So I want you to take 9 and divide it by 4. And tell me what you get, ignoring the whole number and as the decimal. 0.25. If you take the power of i's number and you divide it by 4, and the decimal place is 0.25, then it is equal to I. So what do you think if we take the number, what's after 9? 10. So go ahead.
So like 92 would be 0.50.
Exactly. So the next one would be like I10 divided by 4, which would give you 0.5. So if you get a remainder of 0.5, then it is equal to negative 1. Because this is equivalent to I squared. So I to the 11, which is our example we just did, we said that was equal to I cubed. So if you get a remainder of 0.75, it's equal to negative I, because it's the power of I cubed. 12. What's 12 divided by 4? 3. Is there a decimal? No. So if your remainder is 0, it means it's divisible by 4, which means it is equal to 1. So if you did, the whole reason we're practicing is to take away the confusion. I know this is brand new. I'm trying to give you every possible technique to get you that help. So powers of 4. If you like dividing a number by 4 and getting a decimal, then all you have to do is memorize this. If you understand, great. If not, we're going to practice. If you divide 12 by 4, your decimal remainder is 0. A decimal remainder of 0 is equal to 1 because it's a multiple of I to the 4. These kind of techniques right here are the cycles of I if you just divide the power by 4. So let's take that 91, because maybe you don't know what multiple of 4 is near 91. Like I know it's 88, but if you don't know, what's 91 divided by 4? Go ahead, Aaliyah, do you have it? Well, I don't want the final answer, I want the decimal to teach that concept. So 91 divided by 4, go ahead. 0.75, right? So if you get a remainder of 0.75, that means that this is equal to negative I. Wonderful. $244. Go ahead. Exactly. It's 61.0. My remainder is 0. Therefore, it is a power of 4. Therefore, it is equal to 1. It's also even. Remember, the evens are ones or negative ones. Odds are I or negative I. So you got 50-50 shot. Yes.
Why did we divide it by 4?
Because there are only 4 different answers for I. Like I squared, I cubed, and I to the 4th. After that, everything repeats itself. It's like a circle. It just goes round and round and round. So it's like being top, middle, bottom here. 10. 10 divided by 4. We already did it, right? No. Negative 1. Because 10 divided by 4 is a decimal of 0.5. And it's even.
Oh, yeah, even.
And not, if it's even and not a multiple of 4, it's negative 1. Yes.
Oh, okay.
Now, i's are like x's. You can't add them together. I to the 6 plus I cubed is not I9. I to the 6 plus I cubed is not I9. You have to simplify separately. What did we say I to the 6th was equal to? I cubed is equal to? So I to the 6 plus I cubed is negative 1 minus I. What do you call a real plus an imaginary? That is what? We talked about its name yesterday. A real plus an imaginary is a?
Complex.
Thank you. A complex number. I would love to scroll back up. Yeah, I was going to say the internet just whacked out again. All right, turning your notes to the new stuff. Hopefully, that's the hardest you feel today because the next stuff is treating I like a variable and you're adding and subtracting, multiplying and dividing. So it's back to old school, like adding, subtracting, multiplying, dividing. So in example number 1, please distribute the negative and drop the parentheses. You're skipping last night's homework and going to the new notes. Skipping last night's homework and going to the new notes. Okay, so 3 plus 6i minus 4 minus 8i. You distribute your negative and drop your parentheses. So you get 3 plus 6i minus 4 plus 8i. So 3, exactly, I already heard it. Negative 1. Nope. It's a positive 8 because the negative times the negative is a positive plus 14i. Next. Yes. I said, I hope, like, I know the last part was awful, but I pray this part is easier. Yeah. That is totally fine because addition is commutative, so order does not matter. Now, we try to write them in order of A plus BI, so you try to keep the I's at the end. That's what we call standard form. Why are you confused? What's 3 minus 4? No.
Negative one. Yes.
Please stop. He's from Texas.
Got it. I passed math at Texas. I'm not here.
What math were you taking in Texas?
Geometry.
Yeah, that's why you
That's
passed.
the same stuff.
Hell.
This is not geometry.
Okay, 8 plus 3i minus 2 minus 4i. Combine like terms. What's 8 plus 2? Okay, perfect, because it's negative 2, so you subtract it away. 3 minus 4. So the only reason I tell you to put your I like that is so you don't accidentally think it's like a 1 or like something, like I always throw a curl on it so I don't mix it up with my numbers. Okay, 11, distribute. 7 minus 3 minus 2i. Combine like terms. And my final answer, dear? Perfect.
You said the order doesn't matter, right?
No, but we try to do real plus imaginary because that's standard form. Okay, number 12. There's nothing to distribute. You just drop your parentheses. And when I combine like terms, Leah, excellent. Because negative 6 plus 3 is negative 3i. Now, the reason we had to learn the powers of I before we learned to multiply is because in that next one, they're going to multiply an I times an I, which becomes, but I squared becomes
Negative 1.
negative 1. Okay. So 3 times 8. 24. We already said I times I is I squared. And we already said through process of elimination and trying that I squared is negative 1. So pass.
It's being multiplied.
Like how it was negative, and we had to take the I out. Now it's like kind of rapid. Because like you've got the positive, now you're converting it back to.
Okay, 12i times 7i. 12 times 7. 84i squared gives a final answer of I squared is always equal to negative 1. So if you multiply them together, you change it to negative 1. I know, I sometimes. Okay, 3 numbers doesn't change the rules. Multiply the first 2 together. So you get negative 7 I squared. You can do that. So that's what I was going to say. This takes 2 different paths. Path 1 is change the I squared now to negative 1. So negative times a negative becomes a positive 7 times 4i. 7 times 4. So we get 28i. No. It's gone. You got rid of it. Now, if you follow this path, you have negative 7 times 4, which is negative 28. I squared times I becomes I cubed. But I cubed becomes negative I. So a negative times a negative becomes a positive 28i. See how the path you take doesn't matter? It gets you to the same. If you like one path more than the other, follow that path. It's like the Y in the road. The fork comes back to the same. Multiply the front 2 together before you get to the distributing. 3i times negative 3i becomes
Negative I squared or negative 9i squared.
now you have a choice. You change the I squared to negative 1 and you make a positive 9, or you distribute it in and then change all your i's at the end. So if you distributed it in, negative 9 times positive 4 negative 9 times negative 4 I squared times I, like x, it's like variables. X squared times x is x cubed. X squared times x squared is x to the 4th. I squared is, yep, because you multiply by negative 1 and you get 36. I cubed is what? So you get minus 36i. No, they're not like terms. One has an I, one doesn't. Yeah.
Yeah, Will, why are you
Learning something new today. We always have homework where we learn something.
Maybe like Wednesday, Thursday, somewhere next week. This stuff doesn't go away. It goes into the next two chapters. Yeah. It goes into that.
I like this word in math lesson.
Yeah, but the problem is if you get a negative square root, you need to know I.
You're telling me we're gonna be.
Yeah, that's algebra 2. That's 5, 6. I for imaginary. Alright, 2I times 3I times 3I squared. So I'm going to give you the same thing because I heard that. And my thing I tell my son, I was like a little kid wrestler, is if you believe you can, you can. A negative attitude automatically sets you up for failure. So when he walks into a wrestling match and he goes, I'm going to lose, I go, you're right, you are. You have to believe you're going to win. So, like, no, because that's the mentality of the sport and the mentality of the I saw. It'll be right back up in 2 seconds. By the time I hit buttons, it comes up. Okay. So the idea is that if you say I can't, it's like the choo-choo train thing. I think I can, I think I can, I think I can. The minute you create that negative animosity towards something, then yes. So you believe you can multiply numbers, then you can. So 2I times 3I squared. 3I squared is really like 3I times 3I.
But if you did 2 times 3, wouldn't that also be?
Nope. Because 2 times 3 is 6. The final answer, you have to square the 3 and square the I. 3I squared is really like 3I times 3I. 3 times 3 is? So, and I times I.
I squared.
Yes.
Why would we multiply the 3I first? Why could you do 2?
Because order of operations says exponents before multiplying.
Oh, there's still.
Isn't it like
Yes.
Yeah, I know. I was just wondering. I thought.
Because this exponent is on the outside. It's more prioritized than multiplying the insides. Because if you think once you see my final answer, if you did it your way, 2 times 3 is 6. 6 squared is 36. We're gonna get 2 times 9, which is 18. That is not 36. They're not equivalent because of the way order of operations works. I times I squared is I cubed, but I cubed is, so this is negative 18I. You should never, ever, 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 ever have a power in an answer with an I. You should never, ever, 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 ever have an I to a power in an answer. I know I say that.
Someone already.
So again, order of operations say exponents before multiplying. So 5I gets multiplied. Negative 2 times negative 2 is perfect. 5 times 4 is I times I, but I cubed. Practice. You don't show up to a game without practicing. Exactly. I'm not expecting perfection on Monday. I'm expecting improvement. What do you do if you have parentheses times a parenthesis?
Foil.
Excellent. So first, 2 times 3, outer, inner,
14I.
last, Negative times a negative is always.
28i squared.
I never heard.
We never leave an answer with the power to I because I squared is negative 1. So this isn't plus 28, it's really
Negative 20.
negative 28. I and I are like terms, so you combine them. What's negative 12 and negative 14?
Negative 26. Oh, wait.
But 6 and negative 28 are both numbers. So 6 minus 28 is excellent. So you get negative 22 minus 26i.
Let's go, Will.
What? Yeah. Last one.
You should let us try this one.
All right.
I just want to try on my own.
Because it was multiplied by I squared. So I squared became negative 1. All right. I won't speak. I'll just write. It's really difficult. Thank you. All right. You need to know the powers of I. So if on the next page, which is your homework, front and back, due Monday, if it helps you, we can write the powers of I in the top right-hand corner right now, so you don't have to keep flipping through your notes a million times. So ready? Did everybody get 9 minus 38i? Are we good? Okay. So, I is I. I squared is negative 1. I cubed is negative I. And I to the 4 is 1. That is all you need to know. You also need to go back and do the 4 homework problems from the other day. So if you want to write them at the top of this page, you can. So here, I'll give you the numbers real quick. If you want to put them on this page, you can. But I need I to the 35, I to the 99, I to the 67, and I to the 29. So you can either do it on homework day 1, or you can put it on this page. It was the first 4 from last night that we didn't do.
That's 29.
Yes.